Linear probabilistic modeling. So what is it and when is it used? The linear probabilistic model is a relationship between two variables, in this case x and y, where the expected value of y is a linear function of x, but it may differ from its expected value by a random amount. So we have y as a dependent variable, b naught as the y-intercept, b1 as the slope coefficient, and then epsilon as the random error. Now, this is actually very similar to an equation shown throughout our high school life, where y equals mx plus b. In fact, the main difference in our new equation is that epsilon, that random error that we have to take into account when dealing with any statistical methods. This scatter plot here shows a true regression line with the points showing random deviation, E, which allowed the data to fall above or below the true regression line. A point with no error would be represented by the regression line formula, y equals b1x plus b naught. A good way to think about it is if to think about each point in the line had its own probability curve. The expected value, or mu, is given by our linear regression line equation. But as with most samples in this real world, there's going to be some form of error. Maybe it's a little bit above or a little bit below. In fact, the way the linear regression line is calculated is by minimizing the sum of the squares of these errors from each of the data point to the line. So if we were to go back here and square each individual error and then add them together, the sum of these errors would be less than the sum of any other squared deviation line you could find. Now I want to talk to you about an example with linear regression and something I found interesting to try to do. I wanted to find the linear probabilistic model of population versus energy consumption in the world. So on the left side, you have the energy consumption of a bunch of countries, and on the right side, you have the population of these countries. The first two countries are China, then followed by US, India, all the way to about 150 countries. This, of course, was given to me by the magic that is the internet, and I plugged that information into Excel, which has slowly chugged out the data for me and then into a linear regression model. It gave me that for every one increase in the population, there is an average yearly power consumption increase of about 3,123.4 watts per hour. Now, is this a great regression line? No, but it's interesting to compare two large countries like India and China, their power consumption being so different.